Happy Gurgapi. Hello, students of class 8. Last time we had a discussion about the topic synthetic fibers and plastics, and we have completed that chapter. I'll be uploading you the question answers for you all so that you can write in your copies, and then you, after the school reopens, you all can submit it for correction. Today, since we have completed the last chapter, so today we will be starting with the new chapter, metals and non-metals, right? So when we are talking about metals and non-metals, what happens? Actually, metals, when we think, the first thing, if I ask you to give you an example of metals, then what will happen? I'll find you will obviously tell me that iron. So the say now if I ask you more examples of metals, like even silver is metal. Now here gold is metal, and if I talk about non-metals, then generally what will happen? Non-metals are like phosphorus, then sulfur. These are examples of non-metals. Now. When I means actually, if I ask you that, if you tell me that what is the definition of metals, then what will happen? Obviously, if I have to give you an example, or sorry, the definition of metals, then what are metals? Metals are those elements which have a tendency to lose electrons, and then they become positive ions. Now, lose electrons, why only electrons? Now, what are the constituent elements of an atom? The constituent elements of an atom, as you know, are neutrons, protons and electrons. Now, if you talk about the structure of an atom, so what happens? The nucleus is inside it, where the neutrons and the protons remain inside. So here what happens? These neutrons and protons remain inside, and they cannot move about. That means they are inside the nucleus, they are fixed. And then there are some orbits, which is in those orbits what happens? These orbits, the electrons move around, right? So when the electrons move around, these are orbits, and they are known as stationary orbits. And these stationary orbits are provided with energy for which the electrons can move. That is why they do not fall, because now suppose you are running and running and running, then what will happen? At one time you will be drenched out, and then you will be having no energy to run more. So what will happen? You will have to either sit down or you will fall down, right? Or you are being provided, now when you are being provided with some energy drink, then more you can run. The same thing is that here these orbits are provided with energy, and when these orbits are provided with energy, so that is why the electrons can move around these orbits, and then what happens? They do not fall down in the nucleus. Now, as a whole, the atom as a whole is neutral. That means the positive charge is equal to the negative charge. Now, what is positive charge and negative charge? When you ask me, the negative charge is actually electrons are negatively charged and the protons are positively charged. And in an atom, if I tell you, suppose I take here, you take this example, take this diagram. So what happens? That there is a rule that in the first orbit, that is they can hold 2 electrons. In second orbit they can hold 8 electrons. Just to make your concept more clear, don't get confused, 8 electrons and 8 electrons. So here what happens? Here you see there are how many electrons? 1, 2 and 3. So here, if already you know bit of the elements that are present on the Earth's crust. So it is lithium. Lithium is having 3 electrons. So when lithium is having 3 electrons, 2 electrons are in the first orbit, and in the second orbit there is 1 electron. Now just now I told that the capacity to hold electrons in the second orbit is 8. Then you might be asking me, why only 1, ma'am? So actually here, why it is 1? Because lithium, the atomic number is 3. That is why 2 electrons are accommodated in the first orbit. So how much after accommodating 2 electrons, like suppose I have 5 rupees with me, so 2 rupees I buy 2 chocolates. How much will I be having with me? It is 3 electrons. Sorry, 3 rupees. So obviously I will be left out with 3 rupees. The same thing happens here is that 2 electrons are already accommodated and then 1 is left. 3 minus 2 is 1. So 1 is left. So this 1 which is being left with us will be accommodated in the third cell. So this electron which is in the last cell, this is the last cell for here. So that is why the number of electrons that is present in the last cell is known as the valence electron. And this valence electron is responsible for the valency, or in fact you can tell the combining capacity or the chemical activity of that element. Now I was talking about, when I am talking about metals and non-metals, there are another classification of the elements that is present on the Earth's crust, that is the metalloids. Actually, when you are talking about metalloids, you can compare it more with a sandwich. You have and I know all of you are acquainted with the word sandwich. Some of you might be having it, taking it as a favorite food as well. So what happens, the sandwich, within the 2 pieces of bread there is a layer of mayonnaise, or you put it with garnish it with cucumber, onion, then tomato, and then you take it. The same thing happens here is that between the metals and the non-metals, the metalloids are placed in between the metals and metalloids, and they exhibit why they are placed between the metals and metalloids, because they exhibit the properties of both the metals and the non-metals. Now that is what. So these metalloids, now examples for metalloids are arsenic, germanium, silicon. So those are metalloids, and moreover how am I going to define metals? That when those elements, they have the capacity of losing out electrons and they form positive ions, because electrons are negatively charged, so obviously they will be forming positive ions. And then the opposite is the definition for non-metals, that when they gain electrons and becomes negatively charged ions. And noble gases, they are neither classified as metals or non-metals, because the number of valence electron is 8. For them it's full. So that is why their valency is 0, and they are generally classified as noble gases, right? So they are not metals or non-metals. So now if I talk about, like suppose in the beginning of the chapter lesson I was talking about, like if you see this this one, it is a metal. So when it shines. So this is the property of metals, that means it shine. Then it is solid, but there is an exception to it, that mercury is liquid at room temperature, and it is for that reason it is used as indicator for the thermometer, because it can rise up when the temperature also rises. So if it is sonorous as well. If I just see, you can hear a sound. But if I put a piece of chalk and then put a piece of chalk and then this wood, I put it over here, you won't hear much of the sound. Now it is also ductile and malleable. What do I mean by malleable and ductile? Malleable means when you can put it in a thin sheet, like aluminum. Even your mother might be knowing embossing, where there are thin aluminum sheets where you can beat it into sheets. That is malleable. And ductile is what you can pull it in thin stripes of wires, like gold, then even silver. It is for that reason that this gold is used for making ornaments. Then even copper wires, those are malleable, those are ductile. So we'll have a further discussion on this topic. And till that time, please do keep in touch with your books, because you have already got your books. Have a good time ahead, and do feel free to ask any queries if you have. Thank you very much.